To find the time complexity of the recursive algorithms, you need to follow the following steps. First, from the given recursive algorithm, you need to identify the recurrence relation. Let's take an example of a factorial function. Now, we identify the recursive relation for this function. To do that first, we need to denote the time complexity of the given factorial function as t of n, where n is the size of the input. Now, we need to look for number of recursive calls and also the size of the input for each recursive calls. As we can see that there is only one recursive call and the size of the input gets decremented by 1. So, we can mathematically express it as t of n equals t of n minus 1. Also, we need to check time complexity of the work done outside this recursive call. There is only one multiply operation outside the recursive call, and the time complexity for that operation is big O of 1. So, we add the extra work done with the recursive call. We need to identify the input size for which the algorithm terminates the recursive call, and then we determine the time complexity for the base case. Here, the time complexity for the base case when n gets reduced to either 1 or 0 is big O of 1. So, we can update the recurrence relation as. We further simplify the recurrence relation as. So, we can say that when our input size becomes either 0 or 1, then the recursive call terminates. Otherwise, we go on making recursive call along with one single operation per recursive step. Now that we have expressed the algorithm into recurrence relation, we need to solve this recurrence relation in order to find the time complexity. There are 3 methods to solve the recurrence relation: substitution method, recursive tree method, master theorem. We can use either of the methods to solve it. But master theorem only works for divide and conquer algorithms. We will solve this recurrence relation in the next part.